So I can tell you the solution to a problem I've got. The problem I've got is I have 20 seminar sections arranged throughout the week. You can see the schedule here in front of you. And I have 10 teaching assistants that I need to slot into those 20 seminar section times. So for example, if I pick a time like Tuesday at 10:30 in the morning, seminar 0214 for example, I need to find a teaching assistant that has this time spot free on their own class schedule. So I've got 10 teaching assistants, 20 seminars. That means each teaching assistant will teach 2 seminars. Each seminar will only be taught by 1 teaching assistant. So what I've done is I've developed a cost function. I've basically said, if you're a teaching assistant and you've got a class at the exact same time as a seminar, it's going to be really high cost. We'll make that 1,000. If you've got a class just before or just after, it's not quite optimal. I mean, you can still do it. You can still teach in that time slot, but there is some cost. You might have to get there a few minutes late if you're running across campus, if your earlier class went late, or you might have to leave a little bit early to get to your next class. So that's the idea here. So let me talk about the mathematics behind this. So this is set up as a linear programming type problem. I have my teaching assistants. I have 10 of them, and I use a subscript I to denote those guys. I have seminar sections, and again, 20 of those. So 10 times 20 is 200. I have 200 decision variables in this mathematical programming problem. So it's an assignment problem, so we'll let xij represent our decision variable, 200 of these things. They'll have a value of 1 if a teaching assistant is assigned to a particular seminar, and 0 otherwise. So in the end, in the final solution, of my 200 decision variables, there will be 20 values, 20 xij's that have a value of 1, and the rest will all have values of 0, if it works, of course. And I mentioned the cost piece. So I have costs, and the costs are basically as follows. If there's a conflict, if a teaching assistant has a class scheduled at the same time, the cost is 1,000. You can't make that assignment. If they have a class either just before or just after, then the cost is 10. It is possible to assign them to that, but there is that slight cost. And then finally, a cost of 1 if they can be assigned at that particular time. And then here's our linear programming function. So our objective function here, we want to minimize the total cost. How do we do that? Well, we take our 1s and our 0s and we multiply them by our costs, and we add that up across all of the teaching assistants and all of the seminars, and that'll give us the total cost function. We have a couple of constraints to keep in mind. The first one is that a teaching assistant can only teach 2 seminars, and this constraint here that a particular seminar can only be assigned to 1 teaching assistant. And finally, just for completeness, we have a constraint that all of our values x, I, and j must be 0 or 1, so it's a binary type constraint. So that's the linear programming setup. Let me show you how I solve this using Excel. So this is Excel, and again I have all of my seminar times here in columns, and I've asked the teaching assistants to tell me, okay, Monday, 8:30 a.m. for this first seminar. Alice is not available, so she gives it a cost of 1,000. Anthony is available, so he gives it a cost of 1. Brian has some conflict with that time, but he could make it, so he gives it a cost of 10, and so on. So all the teaching assistants give me all of their costs for all of the seminar sections. Down here in this area, we have the decision variables. So for example, we have Alice and Anthony and Brian. If we were to assign Alice, this Monday morning section, our cost is going to go up by 1,000. But if we assigned it to Anthony, for example, our cost would only be 1. So we're not actually going to assign the cost manually. We'll let the linear programming do that. So that's the idea. This cost function here is the sum product of all of my costs up in this area and all of my 1s and 0 assignment values, variables down in this area. And we have our 2 constraints. So again, if we add up all the ones and zeros down here to get this value, it has to equal 1. We can only have one teaching assistant per seminar. And likewise, if we add up all the ones and zeros across the row for a particular teaching assistant, that sum there, right, that has to equal 2 because each teaching assistant is assigned to 2 seminars. Now it's just a matter of solving the problem. So we'll go Data, open up Excel Solver. This has already been set up for me, so my target cell is my total cost. I want to set it to the minimum value possible. My changing cells are the assignment variables, the 200 cells that you see there. They'll be assigned a 1 or a 0, subject to the constraints. Well, they must be binary, so they can either take a value or a 1 or 0. Sorry. We have this constraint here that adds up everything, down a column and make sure that it equals 1, and then this one, everything across the row, and make sure it equals 2. Of course, it's a linear model. We're going to assume non-negativity like we always do, and then we hit solve. And it found a solution for us, which is great. So we can see that Nicole will be teaching the first 2 sections on Monday morning, followed by Matthew, followed by the other Nicole, and Josh will be taking care of the evening section on Mondays and all that kind of stuff. It turned out my total cost was 20. So there was no conflicts between my original seminar schedule and all of the 10 schedules for each of the individual students. So that was great. So here's what the final schedule looks like. There we go. Right, we can put Nicole into the first couple of seminars here, followed by Matthew, followed by Nicole, Josh in the evening section, and so on across the week. So we have a mathematically optimal schedule, and no muss, no fuss. It was easy to do. Just gather one row of data on a spreadsheet from each of the teaching assistants, pop it into an LP spreadsheet, and solve the problem.